Hello, everyone. Thank you for being here with me. This is a review of the Dayton Audio Imm-6c, which is the USB-C calibrated microphone. The specifications, which are listed on the back of this little guy, it includes a DAC and an ADC. 6 millimeter condenser microphone. Polar response is omnidirectional. Frequency response is 18 to 20 kilohertz. Maximum SPL is 120 decibels with 1.1% THD. Signal to noise ratio is 70 decibels. Connector is USB-C. If you don't know what all those mean, don't worry about it. It's accurate. That's the important thing. On the back of the box, you see the serial number here. This is the one on the bottom, this tag. You'll need that because to use this microphone properly, you need to download the calibration file, which corrects for any slight irregularities in the response of the microphone. So that when you're done, you have a precision calibrated device. Comes in this nice block of foam, which is really good for protecting it from damage. So, and this is amazing to me. This is the little thing right here. Years ago, this would have been so much bigger. Not only does this little tiny piece of equipment contain a microphone, it also contains a DAC chip and an ADC. ADC is analog to digital converter, so it converts it to digital, shoots it out the back, and then the DAC part provides an audio output for the headphone plug on the bottom, so you can plug in your headphones and monitor it directly. Now, this beastie is made for a Android device. So you plug it in and you use this for your testing. Requires you to have the proper software for your Android device. We're going to demo it and test it on a Linux computer, which is actually what I'm using it for. Later on in the video, if I can find some free software. I did a preliminary check earlier and I could only find software that you had to pay for. And since I don't plan on using it on the phone, I don't want to pay for the software. I'm not making any money from my channel since this is a brand new channel. I'm just making enough money to pay for the software, but maybe I can find some for free. I'll look. There's a lot of open source stuff out there nowadays. So, how do we use this on a computer? Well, obviously you don't want to like hold your computer up and try and aim it at your speakers. So what we've got is this USB-C extender cable. By the way, I should mention, this little goodie also comes in a couple of other versions. They're not all USB-C. USB-C is because that's what I wanted for an output that I can plug into my USB-C on the computer. And if you're going to do that, you'll need something like one of these little guys. This is a little USB adapter, USB to USB, so I plug one end on the cable, plug the cable right into that, plug the other end on into my computer. And we're just going to go over here and set this up on a little tripod. Okay, so there's just a little shot of my Frankenstein sound system. Um, that's the crossover on top of the bench with all the wires hanging out of it. I've got the two speakers in a single crossover, and extended the pipe is the extended port tube out of the subwoofer, which you can see there. A phase linear unit, the silver unit at the bottom, is actually my subwoofer crossover built into there. What you can't see, uh, the system is driven by two amplifiers. I've got a Parasound 2125, which I've actually looked at some reviews on and actually seen it win out in the reviews over a Macintosh amplifier that cost $5,000. So I'd say that was a pretty substantial choice. And then I've got a older NAD, one of the ones that's a real monster as far as low end output and doubling into 2 ohms and everything like that. I've got it running in bridged mode. It's only a 40 watt per channel amplifier. In bridged mode it's about 80, but actually it puts out well over 100 without a problem. It's really an underrated amplifier, and it's just a monster. So that's what I've got, but we can tweak it up and adjust it and tune it with our little calibrated microphone, and that's what we're going to. Ideally, you want your testing microphone, of course, to be midway between the speakers, unless you're just testing one side, but we're going to test the whole system as such. So you can see the computer I'm going to be testing it on to the right, and I will shoot a test, and I'll use REW, and we'll get some get a look at that, what REW looks like and how to test it and see the frequency response and stuff, and I'll get some screen grabs from that as we go through. I found the microphone to work flawlessly so far with every test, and the microphone is very plug and play. It's working on my Linux system, which it's not recommended for, though they should, because it works just fine. It's just plug and play with the software. So let's give it a test and see what my frequency response looks like, and then we'll equalize it out and check it again. And we'll see how this works. So far I've found the microphone to be excellent, but we'll test in these other ways, and then I'll try running an audio signal back through it and see how it works on headphones and things like that, which I haven't tested yet. Okay, so let's see about getting a test going here. Okay, so we're going to do some tests using REW, and the Linux sound system continues to give me fits. If you want to do anything with it other than just watch a video on YouTube, even that gives me fits now. Okay, so we're going to check things. Let me start the start a screen recorder here. So we're going to start by checking, make sure our configuration is right. Showing the microphone as an input device, showing our DAC as the output device. So theoretically this should work. Now if we can just get REW to recognize the hardware. We use Pipewire on Linux, and REW often has a hard time. You have to set the microphone and things in the preferences, and a lot of times it won't come up, and if I choose anything other than the proper device, and it's not working, we're not getting our... Okay, so on this one we've got the Imm-6c, which is fine, but we've got to have our default Well, we can try PCM pipe wire and see. It often doesn't work right when I do it that way. What's supposed to happen theoretically is it should list the DAC, and I don't know why, but REW often will not find the DAC. Okay, so we got a little bit of a low level, so we'll just turn up the DAC a little bit. Try this again. That's pretty loud, but I think that'll be okay. Okay, so that's where I'm at right now. So now, obviously the microphone is working great. Turn the subwoofer up a little bit, we'll measure it. Okay. So that's a lot closer to my actual measured frequency response from the listening position. Now, I don't know if you've ever measured speakers yourself from the listening position, but that's not too bad to start with. We go like from a drop here, 75 to 85, so we've got like a 10 decibel drop and a peak here. But if you look at most room resonances in most rooms without any treatment, this is a lot worse to start with. So the better you have something to start with, the better you can get it to equalize out properly. Now I'm going to see if I can get the equalizer working, and this is going to be another potential pain for us. And if it turns into a pain, I'll have to redo this. Okay. So let's just see if the test runs through the card or not. It looks like it did. So looks like we've got some little peaks that need to be equalized out, but overall you can see, let's compare the two. Just put them both on there. Okay, so you can see how the green has went down to the blue. It's been partially equalized out. So we're getting a lot flatter response than that of the green. So let's just knock the green out of there for now. Okay, so for some reason we've got this big peak here. And I don't know why. It's possible one of the controls got bumped up on the equalizer. Let's take a look. This is about, you can hover over it here. This is about 3.26K. Let's look at our equalizer here. So our 3.3K is raised up. So we're going to take you back down. Probably the 2.2K a little bit. Not sure exactly how that happened, but could take 300 hertz down just a little bit. I never set this profile up for proper equalization, so I just did a rough deal on it because I use it with the Carver old sonic holography unit. which I really like the effects. It only has one downside, really, and the reason it didn't, they aren't still using the things, is the fact that it's subject to the head in the vise thing. In other words, it works if you're seated directly between the speakers perfectly. Okay, I'm going to measure this, but I'm going to set our sweep time to be a little bit shorter so this will work faster. Because for this testing, it's fine. We're just doing frequency response testing. Let's check again. Okay, so you can kind of see the changes we made. We brought this peak down a little bit here. Now, obviously, we need to take this one down a bunch more. It's better, though, but we need to take that one down. 3.3, so I'll go a little bit down and more here. About 3.8, which is our next one. Does that need, is that a little high? Actually, that's not too bad for the moment. A little high here at 5.5K, though. Let's see about that. Maybe we'll bring up 10K some more. So, I better sight down our microphone to make sure it's aimed properly. Yeah, we're a little to the left there, so we want to get that. Unfortunately, that's one of the problems. That's one of the problems with using putty for a microphone. This heavy USB extender cable is pulling it over. All right, let's take 10K up just a little bit more, and then we'll check this again. I honestly don't worry about 10K too much. It's showing a bit of a gap, but I can't hear that high. However, that doesn't invalidate setting it properly. Oh, a little bit down on the 10K now. So let's get rid of these other ones to start with, and let's just look at where we're at now. Okay, so not too bad. 3K down more. 10K down more. Generally, you want to that's right about at 3K, isn't it? Okay. Well, we'll just take you down a little bit. What about 2.2? Is it a little high too? Yeah. You really don't want a high spot in this 2 to 3 kilohertz region, because that'll make your treble seem hard and very forward. We still want to take 10K down a little more yet. Okay. All right. Do another test, and that's what you do. You just make little changes, test it, and you'll need to do that a lot. By that, I mean little changes at a time, because it's really easy to overshoot in some cases. This is showing us that that's actually 2.9K. We'll take our 10K down a little more yet. 2.9K. We're mostly worried about getting that peak out. So we might actually need to make, what can we do? That's at 3.3. Maybe we can just change you to 3. We're going to try changing the equalizer here in this 3.3K to 3K. And we're going to test it again that way real quick. So we're going to make it, I'm going to keep it at 3K, I think, here. Obviously needs to come down. Now, if it affects too much stuff, you can change the Q. Too much or too little stuff, you can change the Q to adjust that. Okay, I'm gonna pause recording here now until I get this more straightened up, and then I'll continue. No reason you need to see me correcting and recorrecting over and over again. Okay, we're gonna do one last test. I think we've got this about straightened out. Okay. So there's more or less our current result. And we're going to leave it at that for now, though we can, over time, I'll probably smooth out some of those ripples a little bit more. But as you can see, that's way better. Let's do a test without the equalizer on. So this is how you can use this to set up your EQ to EQ your speaker systems out. Now this is pretty good response from our listening position. We're within about plus or minus 3 decibels over most of it, and plus or minus 2 over a lot, and we can even get it tweaked better over time. So that's how you do that. If you take a look at this, this shows you information about your sound system. So we've got bass basically flat to about 26 hertz. Then our approximate 3 dB down point is like at 23 hertz. So that's a really good response. And we actually have significant output down as far as 12 hertz. But of course that's way down in level. So there you go. That's how to use that nice little measurement mic to improve your system. Okay, so now here we've just done a test before EQ. So this is what we're getting before equalization. Now let's kick in the EQ and show you what we get after equalization. And this is one of the benefits of owning a microphone like this. A calibrated microphone, mind you. Okay, so in the red trace you can see all the deviations before equalization. In the green trace you can see the equalized output and see how much smoother that is. And what that's going to do is lead to a big improvement in the instruments sounding natural and things. It can't fix a bad speaker. You can try. It can make a bad speaker sound better. But the better a speaker measures to start with, or a system measures to start with, the better result you're going to get after equalization. But this is just EQ, no fancy DSP, manual EQ, setting it myself. So, good to go there. We're going to turn this off, and I'll talk about this a little bit more as we quit. I forgot to mention this little guy, this Imm-6c microphone, which is a great little microphone, is only $40. That's without being on sale. So I purchased mine off Amazon, but Parts Express sells little beasties, and they have a good page of information on it. I'd recommend checking there and buying there if you want. You'll need to download the calibration file, and I downloaded mine from the site there at Parts Express. So I tried playing around with a little bit on Android, and I would recommend probably going with the tools that are recommended on the Parts Express page about the microphone, audio tools for Android, and a similar version for Apple. I didn't find anything free that was very usable or that I liked at all. The majority of them I tried will not use an external microphone, so that limits their accuracy to however accurate your microphone in your phone is, which is probably not very accurate at all, I would suspect. Normal phone microphone will be oriented towards speech mostly, speech sound clear, which means without actually checking individual ones, it seems logical that they probably lose part of the high frequencies and probably a lot of the bass, maybe, just because of the device and what it's used for. So if you want to use it on an Android, you can do that. Like I say, you'll probably have to pay for the suite. And since the ones I tried, I didn't care for. Even the ones you have to pay for, that let me do a trial. So try out theirs. I'd almost recommend looking at the software and seeing about installing it first before deciding if you're going to use this microphone for an Android, which there shouldn't be any problem with using it on Android as long as your app lets you select an external microphone. And many of those I tried didn't. I went through probably 10 or 11 of them before I quit fooling with it. And I didn't find a single free one. Well, there was 2 free ones that would work with a microphone, but one of them gave the results in text and not the graphs and stuff I'm used to expecting, so I didn't want to get acquainted with that to figure it out. So do that. It's really a very good value, especially if you download the calibration file. So highly recommended. Oh, I was going to try shooting the output through there and see how that worked. I forgot to try that, but okay, maybe I'll just take a moment and do it right now. Wow. I am totally impressed. I've just got an old beat up pair of Sennheisers here. I don't know how old these things are, probably 20 years old or better. And that thing really sounds good. I mean, I don't have a good quality headphones to listen to it on, but I am absolutely shocked by how good the output of that sounds on headphones. Just running my audio through it. I just popped up a music player, Strawberry, and started playing a song through it by Queensryche, Chasing Blue Sky, and wow, shocked. I don't have a separate headphone amp to compare it with, but yeah, wow. So I didn't expect that. Nice stereo and very, very good. So it's way better than just good enough to monitor what's coming through the microphone. If I ever get any other headphone amps or anything to try, I'll compare it. I wanted to try building one too, so I might do that. But wow. So excellent, excellent, excellent microphone, excellent product. Highly impressed. This definitely gets the DIY Coyote seal of approval. Awesome.